Did I?
Yeah. I don't have anything there.
Because I attached the wrong things together. I feel better. When in doubt, fix that. Which was fine. Okay. All right, ladies and gentlemen, the floor is yours. The recording from yesterday. I had office hours last night. I didn't see very many people, but I hope you took the chance to watch that. That is on the exam. What questions do you have? 272831 or the review sheet? Yes, ma'am.
I was confused on like how to do the secant lines on the graph, like in comparison to like the numbers that they give.
Okay, so in say part A1, right?
Yeah.
You had the line that went through 4 and 8, yes? So you have S of 4 and S of 8. Just give me what those numbers were. Back in part A, number 1. So that means that the slope of this line is 0. But I know it goes through the point 4, 7. I also know it goes through the point 8, 7. So using the slope and one of the points, give me the equation for the line, and then I can graph that on my graphing device. All I have to do is solve for b. In this case, this is easy because this is a 0. I just get y equals 7. So I would graph that line as one of my secant lines. So really, I have to come up with an equation for each secant line from the slope I calculated and the point I'm going to use for all of them.
Thank you.
You're welcome. More questions? Yes, sir.
If you cut a graph from 4 to 2.7.
4. Okay, we know information about a bunch of points, right? So let's take a look in the same idea. Let's take a look at 41. Okay. So in 41, we're told g of 0 is 1. G prime of 0 is also 1. G prime of -2 is 0. The limit as g goes to -5 from the left is positive infinity. And the limit as we go to +5, I'm sorry, I think I wrote the wrong sign there. Limit as x goes to -5 from the right, limit as x goes to 5 from the left is 3, right? And we're only worried about this curve between -5 and 5. So I can start by saying I only look at part of the x-axis. I only care about what's going on between those 2 points. G of 0. That's a y value. When x is 0, y is 1. But I also know this. What does g prime of 0 represent? Okay, well, what's a derivative mean? Slopes. It's the slope of the line at 0. So there should be a little bit of a line going through that dot we just drew, whose slope is 1. Now, I'm going to hang on this one for a second. I know from this limit, as we go to the right, again, and we get closer and closer to 5, we should be getting closer and closer to a y value of 3. I don't think I'm going to hit it because I'm not allowed to plug in 5. So I'm going to put an open circle here. At x equals 5 and y equals 3, and I know that as I come from the left, I should be going to that circle. I know as I go towards -5, I should be going up to infinity. The only other piece of information I have is this one. So let's start with what's on the right side. I know I go through this dot, I'm going up, and I have to try and aim for this. So I'm going to draw the simplest thing that does all of that. It goes up and curls into that spot. So far, so good? This piece of information is not on my picture yet. So let me think about what that piece of information means. It's still G prime, so it represents a slope. And if I have a line whose slope is 0, what does it look like? It's horizontal. So I should have a horizontal line somewhere related to this dot. But I don't know what height it's at. But I do know that I had to be going up at 0, which means if I start to back up, I should come down. I know I need to be going up here, so at some point I got to turn, right? And when you turn, you bottom out. So what I think this is saying to me is that that bottoming out happens at -2. So I can say, all right, I'm going to start coming down. I'm going to bottom out here, and then I'm going to start going up. All I have to do is say, all right, what points do I know? What do I know about slopes? And how can I connect the dots? I think in 40, we actually have more points and more slopes. So I get a lot more information about the same idea. But if I draw those little, one of my other textbooks calls those little pieces lineal segments. If I draw those little pieces of lines, that's enough to help me trace a path. Better? Wonderful. More questions? Yes, ma'am. How to set up a problem like number 6. Sure. How about we do number 5? Very similar type of equation. 2x squared minus 5x plus 1. And what's the point they give me in that one? 3, 4. Great. Now it's asking me for the equation of the tangent line. To find the equation of a line, I need 2 things. What 2 things do I need to get the equation of a line now? Slope and point. I have point, I don't have slope. But as we were just talking, slope comes from derivative. So what I need, they gave me a name for this function, didn't they? They called it y equals. I need the slope of my tangent line at P that is y prime at 3. Now, we have two different ways of getting that slope. Technically, we have 3, but the third one is part of chapter 3, not part of chapter 2. So if you want to use the shortcut, you're in the wrong place. I can use the shortcut to check my work, though. We can use the f of x plus h part, or we can use the f of x minus f of a part. Which one do you want to use? The one with the h. So y prime is the limit as h goes to 0. Again, you have two choices. You could either put in the 3 now, or we can put in the 3 later. Your choice. Put it in now. Then it's f of 3 plus h minus f of 3 over h. If you don't put it in till later, then you have an x throughout this whole problem, and that's fine. You just have to plug in the 3 when we're all said and done. But our f is our equation for y. So f of 3 plus h is 2 times 3 plus h squared plus 5 times 3 plus h plus 1. By the way, if I want f of 3, I could put in 3. But they already did. That's the y coordinate for my point. F of 3 is 4. So I don't have to do that calculation separately. F of 3 is 4. Means I have a sign error. I have a sign error. That's a minus sign. Whew. I was wondering why something looked wrong. Got to copy the problem down, write everything up. From here on out, it's algebra. And then right at the end, there'll be one limit. Let's put this in here. But before I do, I'm going to multiply it all out so that it's easier to put in. 2 times square this part out. First part squared plus 2 times the first times the second plus the second part squared. I FOILed it out. Minus 5 times 3 plus h plus 1. Distribute the 2. 18, 12h, 2h squared, minus 15 minus 5h, distribute the minus 5, plus 1. That's next. Combine all my like terms. 18 minus 15 plus 1 is 4. 12h minus 5h is 7h and 2h squared. Now, y prime of 3, limit as h goes to 0, this thing, minus this thing, over h. If I just plug in right now, I get 0 over 0. I don't like that. So let's do the algebra to simplify this. What happens with my 4's? They're gone. But now it's still 0 over 0. But everything in my numerator has an h. Factor that h out, cancel with the h on bottom. Take that limit. Because the h becomes a 0. That piece goes away. There's my slope. And the point for my line is still 3, 4. Yes, ma'am. Sure, absolutely. I need to now find the equation for the line. You can do y equals mx plus b, because we have y and x and m, and then you solve for b. Or you can do y minus y0 equals m times x minus x0, since you have an x0, a y0, and an m. I tend to think of it that way. I have a point and a slope. I'm going to use the point slope form. And now I multiply that. On this side, I get 7x minus 21. I'll move the 4 over, 7x minus 17. There's my tangent line. The hardest, ugliest, nastiest part of this is the algebra. The actual limit was really easy once I got to that point. Better? Now, you wanted to see this with the x still in it. Okay, so the difference is going to be back up here where we had 3 plus h. I'm going to do x plus h. And multiply that out, same way. Square the first part, 2 times the first times the second, square the second. Multiply through. 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 1. I also need f of x, right? Because I can't use f of 3 this time. So I just copy down my f of x again. Now let's set up the same limit. Y prime of x is the limit as h goes to 0. 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 1. Good Lord, that's long. Minus this 2x squared minus 5x plus 1 all over h. I ran out of room right there at the bottom of the page. I apologize for making that h so tiny. I canceled the 4s. What can I cancel here? Just in the top.
The 2, 5.
So what am I left with? Just in the top. I'm left with 4xh. I'm left with 2h squared. I'm left with minus 5h. And that's it. Everything has an h. Factored out, cancel with the h on bottom. As h goes to 0, that goes away. Now that's the equation for my slope at any x value. That's my derivative as a function. That's y prime. But I wanted y prime at 3. Plug in 3, what do you get? If I don't get the same number, we effed up somewhere, but we got the same number. And then we do the same thing. Yeah, that's fine.
What about the squeeze theorem?
Yeah.
I thought you were gonna settle on one.
Well, we can do the one on the review sheet. But before I go on, remember we have f of x right there at the middle of the top of the screen here. If you use the shortcut, what's the derivative of 2x squared? What's the derivative of 5x? Derivative of 1. Derivative is 4x minus 5. I love being able to check my work. Okay, the squeeze theorem problem says to me, I know that, here's where I go back, of the formula sheet, of the review sheet. I know that cosine of x is less than or equal to f of x is less than or equal to 1 over 1 plus x to the fourth for negative 0.8 less than or equal to x less than or equal to 0.8. Find limit as x goes to 0 of f of x. Oh dear. But you already said the magic word. You said squeeze theorem. Why do you know the squeeze theorem can be used here?
That's right.
I need 2 other pieces of information to be able to use the squeeze theorem. But yes, I'm on an interval and I have a low function, a middle function, and a high function. That's the setup for the squeeze theorem. I need continuity. And then I need to know, say that again. That's the intermediate value theorem. The squeeze theorem requires those to come together to have the same value. So my third one gets trapped in the middle. So I say to myself, I know y equals cosine of x. What kind of function is that? That's what its picture looks like. What category of function is that? Somebody just muttered. It's a trig function. And trig functions are continuous wherever they are defined. And this function is defined everywhere because it keeps wiggling back and forth. This one is good everywhere. That means it's definitely continuous in the interval we want it to be continuous in. What about 1 over 1 plus x to the fourth? What type of function is that? It's division, right? It's a ratio of 2 things like a fraction. That's a rational function. Rational functions are continuous wherever they are defined. Both of those sentences come from the box labeled Theorem 7 on page 120. Rational functions, trigonometric functions, are continuous at every number in their domain. So now I have to ask the question, where is this not defined? Ooh, check that again. You can't divide by 0, right? So what happens if you set the bottom equal to 0? If I try and set the bottom equal to 0, I get x to the fourth power equals -1. Can you raise something to an even power and get a negative? This never happens. And that means the bottom is never 0. If the bottom is never 0, it works everywhere. My domain here is everywhere. My domain here is everywhere. My continuity is everywhere. I just happen to only care about negative 0.8 to 0.8, but I know the continuity works in there because it works everywhere. Now, the last thing I need to be able to do for the squeeze theorem is to say the limit as we go to 0, because we're trying to go to 0, I need to know what the limit as we go to 0 of this is. I need to know what the limit as we go to 0 of this is. If we are squeezed in between to the same number, then I'll have a value, won't I? This function is continuous. How do I find the limit? Plug in. This function is continuous. Find the limit. Plug in. What's cosine of 0? 1 over 1 plus 0. The value I'm looking for is between 1 and 1. What's between 1 and 1? 1. And somewhere up here, I know this is true. I've just run out of paper, so I'm going to grab my next sheet and right at the top of that sheet, I'm going to say by the squeeze theorem. I am continuous in the section I am looking for. I have this chain of inequalities, and the ends go to the same place. I'm squeezed in there. Well, I need to check my interval. Are they continuous here? Maybe if I were to use tangent is messed up at pi over 2, right? But pi over 2 is 1.5. So I don't care about that because that's outside my interval. I only care about what's going on in here. I got lucky. These happen to be continuous everywhere, but I need them to be continuous in that section. One of the important pieces of using any of the theorems we've got is to make sure we have all of the hypotheses satisfied. That's why I had to check, are these continuous? Is the inequality in the order that will be useful to me? And do the numbers get there? Then I can use this conclusion.
But what was like 1 is less than or equal to the limit of the function is less than or equal to 2.
Then I have no idea what the value is, do I? What you're saying is it's between here and here. There are a lot of numbers in there, aren't there? I haven't squeezed tight enough. Otherwise, I don't get to use the squeeze theorem. The squeeze theorem only works when the outside squeeze together and touch. Better?
Yes.
More questions. 52B. What you said.
I guess it's confused as to what it's referring to, if it's referring to the quantity or the price.
Well, look at the equation above that. The equation says Q is a function of P. So f prime of P is the change in F with respect to P. What does F measure? What does F measure? Quantity. So this is change in quantity with respect to price. Commodities pricing, supply and demand. You did these in the algebra classes as examples of functions to find equilibrium. Remember this? No, it's been washed from my brain. I forgot it all. I'm gonna wash that course right out of my hair. Not happy, so it's all stepping. Yes.
Okay. On 2.8, I was confused on how I don't know, I guess do some of the algebra that goes with it.
34 on 2.8.
Yeah, can we do a similar problem where there's like a x in and a fraction of x? If there is one.
I'm looking at the parts that are above that. Oh, I think there's an example earlier in the text. Back in section 7. Yes. Page 142. There's an example that does 3 over x. Because it's the over x that's giving you the problem, right? Okay, so we'll just do this one. Well, okay, if that's f of x, what's f of x plus h? No, it's just f of x plus h. So it'll still be an x down here. I'm not plugging in a number yet. So now if I want to do f prime, it's the limit as h goes to 0, this piece, minus this piece, over h. Blah. So here's where most people, and I'm going to lump you in on that category, go, this algebra sucks. I need a common denominator. The only way to proceed from this is to get a common denominator. That means I need to multiply each of those fractions by the opposing denominator. So here, I'm going to put x plus h over x plus h. And here, I'm going to put x over x. Okay. That makes this first fraction 3x over x parentheses x plus h. That makes the second fraction 3 parentheses x plus h over x times x plus h. But now I have the same denominator, combine those two fractions at the top. And I get 3x minus 3 parentheses x plus h over x plus h all over h. Can't forget the limit as h goes to 0 out in front. What happens on top? I absolutely can. And that makes this 3x minus 3h. Now, I should have this whole fraction over h, right? But fractions within fractions make me unhappy. Rip it and flip it. Rip it out of the bottom, flip it over. The h that comes out of the bottom now becomes a 1 over h. And my h's cancel from there to there. Limit. H goes to 0. Negative 3 over x plus h. That's definitely not going to be 0 over 0. But what happens down here when I take this limit? Because I'll have x times x. You had a 1 over x. Don't worry about the 3, but the process is the same. You're welcome. Jolanta, you had your hand up. Was that about this or about something else? Okay. Before I do that, remember, 3 over x is still a power, isn't it? I know I'm in the wrong section. Let's cheat. Let's use the shortcut. If I were to write 3 over x using powers, what would happen with this x in the bottom? X to the negative 1 power. And then my derivative is 3 times minus 1 x to the minus 2. That's a negative 3. That's an x squared in the bottom. We got the right answer. Oh, I like it. Okay, Jolanta, hit me with the question you got. Yeah.
Number 80.
182, number 40. So that's chapter 3, section 1. Talk to me. Well, that problem has a root in it, right? So my real question is, what happens with roots? Well, we have another problem earlier. Take a look at 21. I don't think we had to do 21. I think we had to do 24, but that's also got a root in it. So does 33. 17 has 2 different roots. Let's look at 17. 17 is f of x is 1 over the square root of x plus the 4th root of x. So, as Chloe just said, when I've got stuff in the bottom, it comes out as negative powers, right? But I need to know what power of x a root is. What power of x is this square root? A root is a fractional power, and the denominator of the fraction is the order of the root. If it's a square root, that's a second root. So I want a 1/2 power. This is a 4th root. Exactly. But this is in the bottom. So before I can actually use the power rule, I got to take it out of the bottom, and it becomes a negative 1/2. I have not done any derivative yet. This is still f. All I've done with is f with it. So that's why you'll notice there's nothing different over here. Really, I should keep writing f of x equals f of x equals, but I kind of just chain them all together. Now I'm going to do a derivative using my shortcut rules. So what happens to that x to the negative 1/2? Exactly. And my x to the 1/4?
I mean,
You are absolutely welcome to leave this like this. The back of the textbook won't. The answer off of Wolfram Alpha won't. It'll do all the simplifying, which means it'll put the square root of x cubed on the bottom here. It'll put the 4th root of x cubed on the bottom here.
like, it gives you the points to like plug in the result like the x value.
So all I have to do is put in the x value to get a slope, right? How do I get the y value?
You have to put it.
I have to put it in the original equation. I get the y value from here, I get the slope from here, then I have x and y and slope, and you give me a line. You're still looking all furrowed. Let's make one up. What if I told you that x was equal to 1 in this problem? Well, then I would say, what's f of 1? 1 over the square root of 1 plus the fourth root of 1 is 2. That's my y value. My slope is f prime of 1. So that's negative 1/2, 1 to the negative 3/2, plus 1/4, 1 to the negative 3/4. My advantage here is that 1 raised to any power, no matter how many times you multiply 1 by itself or take roots, it's always 1. So that's negative 1/2 plus 1/4, or negative 1/4. Y minus y value equals m x minus x value. There's my line. Okay.
Since we don't actually know the quotient rule yet,
There's nothing quotient about this. Okay.
can you split it up?
I hope so.
So the limit laws.
Oh, yeah. I can split it into 2 fractions.
Together.
Multiply what together?
Like if you were to take it as a derivative of 1 over x squared multiplied by the derivative of root x plus x.
No, because derivatives don't multiply like that. But what I can do is I can take that, what you just said to me. You said 1 over x squared times root x plus x. Which one's first? Plus x. Well, wait a minute. That's in the bottom. I don't like things in the bottom. That's x to the minus 2. What's the square root? And x is just x to the 1. If you multiply,
Okay, so you want to multiply out that way.
then I can use the derivatives we know how to do. It would be nice if there was a derivative that would help me figure out what to do with dividing, or a nice way of doing derivatives when I'm multiplying. That's what we'll do tomorrow.
Will that be? Never mind.
More questions? Somebody last night emailed me a question. Is the review sheet really it? Like, no. You've got homeworks you've seen. You've got the keys that are on our Canvas page, all of the homework keys. The review sheet key will get posted tomorrow. But you also have all of the examples and all the things we've done in class. I'm not going to ask you a question you've never seen before. I may ask you a question that requires you to remember things from different places in the textbook. But you will have seen every question somewhere. I don't like the idea of, oh yes, on page 37 in the footnote, you have to remember this sentence. I have a t-shirt my mother-in-law gave me a couple years ago for Christmas. Everything I say will be on the exam. I wear it as a joke because it is. Yes, ma'am. The unit circle? Well, if we did another problem like cosine, and I needed one of the values out of it, I should probably have the unit circle. I still stand by my trick. Your unit circle is on your hand. I did show you that trick, right? Some of you are nodding and some of you are going, what the fuck? Okay, hang on. We'll do it real quick anyway. Hold out your hand, hold your pinky parallel to the desk in front of you. Look at the angles you've made. You've made a 90-degree angle with your thumb. And then you've got 60, 45, and 30 with your other 3 fingers. So you've got 5 things. And in angles, that's 0, pi over 6, pi over 4, pi over 3, and pi over 2. Because I'm a sick mother who likes radians. If you're doing sine, start down here. If you're doing cosine, start up here. If you start counting, C comes before S, right? So start counting C first, S. That's how I remember which end to start at. Start with 0. If I'm doing sine, I go 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Take the square root of that number and divide by 2. Square root over 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 2. What's square root of 0? Square root of 1 is just 1. Square root of 2, I'll leave like that. Square root of 3, I'll leave like that. What's square root of 4? 2 over 2 is 1. There are my sine values. You want cosine? Start at your thumb and count down. Cosine, 0, 1, 2, 3, 4. Same thing, take the square root, divide by. Now, the only thing I have to remember is first quadrant, second quadrant, third quadrant, fourth quadrant. Which things are positive, which things are negative. And I'm pretty sure I gave you the remembering trick for that too. Because if you remember what's positive, you can do it with the unit Cartesian plane, right? Here's X, here's Y. Here's my favorite part. All students take calculus. You're in a calc class. All students take calculus. All of them are positive. Sine is positive, but cosine is negative. Tangent is positive, but sine and cosine are negative. Cosine is positive, but sine and tangent are negative. Now I know what's positive, what's negative, and I just turn my hand for whichever quadrant I want to be in. I have not needed a unit circle since I have 5 fingers. I will tell you, though, I got in trouble with this. Because I've had in the past people who did not have both hands or necessarily 5 fingers. I had a student in Calc 3 2 years ago who only has 1 hand. So she's writing stuff down. She can't look at her other hand to do it. I said, I apologize, but this is the way I was taught. I was teaching parts of the physics in that class, and there's this right hand rule, and she doesn't have a right hand. I was like, yeah, just do this instead. We'll make it work. One of the wrestlers, whose, to my amusement, last name is Wrestler, was a student of mine. And again, 1 hand. So I had to mark this up for him too. Anyhow, that's my unit circle prep, Jolanta. I can memorize it or I can use this. There are blank unit circles available in the Math Enrichment Center. If you want to take one home and write on it over and over and over until you've recited these numbers, that's fine. They even have them that are laminated, so you can write on them with dry erase marker and wipe it off and do it again. And again and again and again until it embeds in your brain. More questions? Yes, sir. That's a really good question, and I wish I knew the answer. I'm pretty sure I think it's 7 total pages. I think each page only has either 2 or 3 questions on it. So at all parts for all questions, it's maybe 15 questions altogether. Hang on. Say again? Yeah, you'll have the entire class period. You'll come in, I'll hand it out, we'll go to town. And then the 9, 10 o'clock, I'll go, okay, people, bring it in. Nope, because there might be another class, people won't all be able to get here. I would love to do that, but I was told it was actually against the rules for the university for me to let you start early because people in other classes would then be at a disadvantage. I don't know who has 8 a.m. classes. Nope. Not for this exam. There were really only 2 formulas in the whole exam, right? The 2 definitions of derivative. Everything else is rules, right? Yes, ma'am. I am not going to ask you to write a theorem. Oh, no, I understand that. But state from memory the theorem is not a appropriate piece of our good use of our time here. There were places in courses where that was part of it. I have always looked at that and said, that makes me want to hurl. I'm not going to do that to you. In the theory class, maybe, but this is not the theory of calculus. That's SMA 207. If you don't have to take that, you never have to do it. And then even then, I don't think we actually memorize them. We talk about them a lot, but I don't think we memorize them. 2.8, yes, ma'am.
Number 42, just like a theoretical question. Are we kind of holes in terms of movable discontinuity case? Is that considered not differentiable?
Yes. You just said it is a discontinuity.
Okay, but
I don't care that it's removable, it's a discontinuity. In the function, it's not fixed, therefore it's not continuous.
what if it's fixed at that point? Like it's defined where the line is continuous, but not by by 2 different functions.
You just said it's continuous. You said if you fix it just right and it's fixed, then it's fixed. But if it's broken and it's still broken, then it's broken. You're absolutely correct. I promise I'm not asking you trick questions. My goal is not to F you over here, people. I want to know if you know this stuff, not if you can read my mind and find the trick I'm trying to get. I'm already picked up enough. You don't want to be in here. Yes, ma'am. The first graph that I did. 14. This one. Because that was where I started. Or you mean this one, where I did the line? Okay, talk to me. Oh, sure. I'm happy to leave it up there.
We could include it for that? Or is just the graph of so
I don't need the equations. You need them to make the graph. I need a picture.
just need them.
I need a picture.
Yeah, other question, another concept question.
You okay if I move this now? Or do you still need, okay. Talk to me.
Graph, the graph of the derivative. Increasing is continuous versus decreasing is like above or below the x-axis, correct?
Right? If this is F. I'm going to say over here my slopes are positive. But over here my slopes are negative. I should do something like that. Here my slopes start to get positive again, but they're very little, aren't they?
So it is whether it's above or below the x-axis. I've been looking at.
A positive slope, a negative slope. So I don't have numbers anywhere on here, do I? So I can't exactly measure them. Is irrelevant. It's whether they're positive or negative.
And
Yeah, well, if I ask for the graph of second derivative, then weird things happen. But I haven't done that.
thank you.
You're welcome. Jelanta. 60 and 3.1.
Page 183. Should we just like around on our calculator or send it the form?
There is a formula. Because in that problem, I am asking you about a tangent line, right? And I'm asking you, where is the tangent horizontal? What does it mean for a line to be horizontal? All right. What can you tell me about this line? Say that louder. The slope is 0. How do I get the slope from the equation? Not of the line, but of the function. Oh, right, it's a tangent line. The slope of the tangent line comes from. So I take the derivative and do what with it? Make it equal to 0. And then I figure out what the x is. I don't need the y. I just need the x values. That problem said, what x values? So all I care about is the x values. We will be doing that a lot. We will be finding places where my tangent line is horizontal frequently. That's part of one of the utility pieces of calculus. What do we use it for? Yes, ma'am. Question, which one? 4. Oh, wrong place, wrong place. Hang on. For this picture, the result is probably not really a parabola. Because this isn't really the appropriate graph to give me a parabola. Because of the little curly bits at each end, it isn't really right for just a parabola. But again, yeah, I'm not being hyper precise here. I just want to know that you get kind of the right shape. There will be no part of this course that is graded on artistic merits. I kid you not, I had a committee meeting yesterday afternoon where we talked about using VR in class and using augmented reality and extended reality goggles and things like that. And I said with a completely straight face, I have trouble teaching my students how to draw and visualize these things on a piece of paper. Imagine if you all put your VR goggles on and started trying to manipulate these graphs that way. But there are three-dimensional graphing programs and three-dimensional data analysis programs that really do that very well. But we all kind of look like either Tom Cruise in Minority Report flinging stuff around, or Tony Stark in the Avengers moving all the stuff on the screens. Just give me more chalkboards. I'll be fine. I have a book that's almost 40 years old about how to draw a map. I've been struggling with this for 4 decades, people. This is a crappy drawing. It's good enough to get the idea out there. I don't want to just give you a peek into the craziness that's inside my head and say, here, look at the picture. I want you to figure out what the picture's supposed to be like so you can make the connection between graph and its derivative and where we're moving and how fast we're moving. Eventually, so you can use it in whatever you're going to go into. And your perspective of things may be very different than mine. I don't know, maybe you're a forensic scientist and the thing you're going to use the most about rates of change is cooling dead bodies. You know the picture in NCIS where Ducky comes along and sticks the thermometer into the guy and goes, he's been dead this long? That's a calculus problem. We'll do it. Give us another couple weeks. Maybe you'll be doing, oh, you're a bench chemist. How long do you have to wash something before it's truly clean? I don't. That's why I don't know how to play this for, damn it. But I'm rinsing out a flask. How much of my chemical is still left in it? Well, if I rinse it with pure water and I empty it at this rate, how much of the chemical is in there at any given time? Maybe that's the piece I need. That's a calculus problem. We'll do it. The one I like the best is pharmacokinetics. You take a drug. I had 300 milligrams of caffeine in this Celsius. I'm going to twitch for a week. Or maybe your body metabolizes caffeine at this rate. How long until that sucker wears off? You take a GLP-1 medication for weight loss. Here's my Mounjaro. I took it on Sunday. If I were to take that today, it wouldn't be out of my system for a week. That's why it's a weekly injection. My wife, the reason I was not in class, was my wife had to go to the hospital. Everything's fine. She had an elective procedure, and originally she didn't remember whether she was going to be under local anesthetic or under total anesthetic. And my wife doesn't wake up very well. And last time she went in for a surgical procedure and needed local anesthetic, they kept her overnight because she's not waking up. So they wanted me there in case medical decisions had to be made. She's fine. Carpal tunnel, cubital tunnel, 3 fingers. She was on the table for an hour. She couldn't do the surgery last Wednesday because there was too much Mounjaro in her system. Because the pharmacokinetics hadn't worn off well enough. It is quite literally a calculus problem, the rate at which the drug decreases. Useless stuff. Never going to see it anywhere. I don't care what field you're studying. I'll find your calculus piece in. We're everywhere. More questions? The summer of my freshman year, my roommate's favorite thing was stock car racing. And he challenged me and he said, where's the calculus in stock car racing? I said, fuel consumption, aerodynamics and drag, tire wear and pit stop timing, camber and toe for the force pushing you up the embankment. And he just stopped and stared at me and went, what the? How do you know so much about car racing? I don't, but here's my physics book with all of these examples of calculus in it. More questions? Yes, ma'am. The derivative of an exponential is an exponential. The derivative of e to the x is e to the x. That was the Pokemon joke at the end of the video. You use derivative. It's not very effective. By the way, that's one of the ways we define E. E is the number for which the derivative of a to the x is equal to a to the x, not a to the x times something else. That was one of the definitions of E. That was actually not the definition that Napier used when he worked with logarithms, but it was one of the definitions that I think Gauss worked with when he was doing the calculus part for exponentials. I really like LNs. Don't give me decimals unless you absolutely want to, but I like LNs. There was another hand. Yes, ma'am. The difference, the derivative of a to the x is different. But that's because it was on the notes. There's that extra thing that we multiply by, right? And that's only 1 when the base is e. If the base is anything else, we're going to get something weird. I will address that in 4 more sections. There's a way to work around it. I really only ever use e as a base, but that's because I can take all the other bases and change them over. You did that in the algebra class long ago in a distant land. There was a change of base formula for logarithms and a change of base formula for exponentials. And if you've forgotten it, we'll remind you of it in chapter 3, section 5 or 6, wherever that comes up. Yes.
The exponential equal to constant.
Well, that's how I gotta get rid of the E, right? How do you get rid of an E? If I have e to the x equals number, I need a logarithm. Was a long time ago, Jolanta. It was. Ah. That no, we need them desperately. Again, I'm going to show my age. You should Google the Ren and Stimpy video for log. There's a jingle there. It's a cartoon.
Well. I feel wrong to believe the variable, like as. Variable.
But if we do the derivative with the power rule, doesn't it still have a variable in it? I just chose A instead of X.
I don't know why, but I marked C as having a question,
Hmm.
but I don't know what I'm like.
When you figure it out, come over to the office hours and ask me, or shoot me an email.
But then I was also gonna ask for D. Are we supposed to use actual value in the way I think?
No, I don't need the absolute value.
So do you negative?
Yeah, because I'm going down, right?
Well, last vector, so I wasn't sure.
According to the textbook, it says we launch it with an upward velocity at 10 meters per second, right?
So coming down to me.
So coming down can be negative. They gave me a direction. That is the weirdest part about the physics of motion. You can decide which direction is positive and which direction is negative, and you can change them in different problems. Only if we happen to be at the same landing height and initial height and in a flat plane. So no. I think there's a problem about throwing a ball off a cliff that we'll do later on. I think it's one of the examples in the text. And you launch from a height of 400 feet. 432, I think. And then you want to know how fast it is when it hits the ground, and then you can't use it. But if you know a little bit of physics, you can cheat, use the physics you know to check your answer.
I guess, like, you don't know, and to your point, you don't know where the frequency is going to come.
We are launched upward with a velocity of 10 meters per second. If we throw something straight up, technically it comes straight down. It's what it hit where it started from. So tomorrow, you'll come in and give me all these homeworks. At the end of class, I will post all of the answer keys, as well as the answer key to the review sheet. You will then have them all weekend to study from. And on Monday, we have an exam. So if you've got questions, come to my office hours that start in 20 minutes, or email me, and I will see you all tomorrow. Say again? Yeah. Let me hit stop on the record.
Yeah, it's